Now let's see a couple of examples from these four cases. We can start with the constant acceleration case first. So let's start this problem in which it says that a particle moves along x-axis with an initial velocity of 50 feet per second at an origin when t was 0. For the first 4 seconds it has no acceleration, and thereafter it acted on by a retarding force which gives it a constant acceleration. A is minus 10 feet per second square. Calculate the velocity and x coordinate of the particle for the conditions when time was 8 seconds and when time was 12 seconds, and also finally determine the maximum positive x coordinate reached by the particle. So since there is only one axis involved in this motion, it's a case of rectilinear motion, right? And the information given to us, let's write that down. So to us, the given information is, first of all, velocity is constant value for first 4 seconds, right? So when t is equal to 0 to 4 seconds, v is equal to 50 feet per second, right?
Sec is not a SI unit again.
Yeah, but the problem is in US units, right? So try another time.
It's in sec. Doesn't it still use S in US units?
No, in US units we have SEC, right?
I didn't know that. Because
So
some of them use S.
they actually shouldn't use, if they are using the problem in US units, you should write SEC, right? The symbol for second is SEC. So the first information given to us is that for time 0 to 4 seconds, velocity is 50 feet per second, and from 4 seconds onwards, we are not given what velocity it is, but the acceleration is given. So A will be minus 10 feet per second square for t is equal to 4 seconds onwards, right? And we don't know up till what time that motion continued, right? That information is not given, but we know that from 4 seconds onwards, acceleration is a constant value, right? For first 4 seconds, acceleration is also a constant value because velocity is constant, which means acceleration is 0, right? So v remain constant for first 4 seconds, which means acceleration is 0, but from 4 onwards, acceleration have a value minus 10 feet per second square. So this is the total information given to us, and to determine, actually if you see, we have to determine 3 things here. First thing is what is the velocity at t equal to 8 second and at t equal to 12 second. So v should be determined at t equal to 8 second and also at t equal to 12 seconds, right? The second thing is we have to determine x coordinate, which means displacement, also at the same 2 times. So s need also be determined at t equal to 8 second and at t equal to 12 seconds, right? The third thing we need to determine is find the maximum positive x coordinate, which means maximum value of s, right? So maximum value of s need to be determined, right? So the solution approach for constant acceleration case, this is constant acceleration case, right? And it will be, actually it was case A, case A out of all 4 cases. Solution technique should be to integrate 2 times and get the velocity and displacement versus time relationships, and then we can answer all questions like what will be the velocity at that time, what will be the distance corresponding to this time, right? So let's start the first thing, which is value of v need to be determined at t equal to 8 second and at t equal to 12 second, right? If we start with plotting velocity versus time relationship, v versus t like this. We were given with the information that from 0 to 4 second, maybe some time here, 1, 2, 3 and 4, the velocity was constant equal to 50 feet per second, right? 50 feet per second. So we should have a flat line for first 4 seconds, and then from there onwards we don't know, it depends on what function we derive by integrating that constant acceleration. So from 4 onwards we were given with an information saying acceleration is minus 12, right? So we need to integrate that acceleration to know velocity versus time relationship from 4 onwards, right? And that integration also should start from t equal to 4 second onwards. So a is equal to minus 12 minus 10, I think, yes, minus 10 feet per second square, right? And that is actually from 4 second onwards, right? So we can apply equation 2 now. Equation 2 is dv is equal to a dt, right? A is given as minus 10, and in integration form it will become v will actually be starting from 50, the starting value of v will be 50, and it will go to any value of v after 4 seconds. So let's represent it with symbol v. The limits of time will start from 4 seconds, and any time after 4 seconds, let's represent it with t, right? So I write the same equation 2 in integral form, but I put the limits which were specific to the problem given to me, right? So my problem was actually what will be the velocity from 4 second onwards, because the question is to calculate velocity at 8 second, 12 second. So in order to calculate velocity from 4 second onwards, I need to integrate acceleration, but that acceleration need to start from 4 second onwards, right? So the lower limit of v will be the value of velocity at 4 second, and lower limit of time will be 4 seconds. So let's evaluate that integral. It will become v with a limit of 50 to some value of v is equal to a is minus 10, right? Minus 10 t, and the limits of t will be from 4 to any time t, right? This should result in v minus 50 is equal to minus 10t plus 40, right? When you apply the limits upper minus lower. And finally we can calculate v as a function of time. V is equal to minus 10t plus 90. 40 plus 50 is 90, right? So this bottom equation is governing the value of velocity from t equal to 4 second onwards. So if we want to complete this graph at the top, we can plot this equation, right, to just see how the value of v is varying. From the shape of equation we can guess that it is a linear function in time, so we should get a straight line. So let's complete that graph quickly. So the equation is governing from t 4 second onwards. So 4, 5, 6, 7, let's go all the way up to maybe 8, 9, 10, 11 and then 12, right? So you can carry out that equation. For example, v will be, for t equal to 4 second, it will be minus 40 plus 90, so 50, right, in feet per second square, feet per second. And then for t equal to 5 second, it will be 40. T equal to 6 second, it will become minus 60 plus 90, 30. For t equal to 7, it will become 20, then 10, then at 9 second, it will become 0, right? For t equal to 9 second, v will be 0. For t equal to 10, it will be minus 10 now, minus 20, minus 30, right? So which means it will look like something like this, like 5 second, 6, 7, 8, 9, 10, 11 and then 12. So let's plot it only up to 12 second. So at 9 second its value becomes 0, and then at 12 second its value become minus 30. So actually it's a straight line passing from 9 seconds, right? Something like this. So this value actually is minus 30 feet per second, and this value is, starting value is 50 feet per second. So actually we can graphically answer this question now. Value of V at t equal to 8 second is what? 10 feet per second. The value of t at 12 second is minus 30 feet per second. But let's actually determine the same values from equation. Actually you can simply put t equal to 8 second here and 12 second here to finally determine that analytical solution. So at t equal to 8 second, V is simply equal to minus 10 times 8 plus minus 10 times 8 plus 90, right? So it will become 10 feet per second, and then at t equal to 12 second, also you can carry out the same thing. V is equal to minus 10 times 12 plus 90 is equal to minus 30 feet per second, right? So first question is answered already, that value of velocity at two different time instants. So now let's move to part B, which was about displacement. So we have to determine displacement at both of these times, t equal to 8 second and t equal to 12 second. In order to determine displacement, what should we do? Integrate that equation one more time, right? So apply equation 1 actually. So let me just continue the same part B now. So the part B was, what is the value of S when t is equal to 8 second and also when t is equal to 12 second. So we already have derived this equation, and V is actually minus 10 plus 90, minus 10t plus 90, but this equation is actually from t equal to 4 onwards, right? Please do remember that V was equal to 50 feet per second, a constant value for t equal to 1 to 4 seconds, right? So this is actually the complete information about V and t. So we integrate that velocity equation to get displacement. Actually we apply this equation 1, ds is equal to v dt, and actually in integration form it will be from s naught to s, and v dt means from 0 to any time t, right? But we know that the equation we have for this value of velocity is not actually starting from 0, right? So actually we will be dividing this integration on the right hand side in two parts. In first part, the value of velocity was a constant value 50, right? So I can write it as, let's say, 50 dt, but from 0 to t, 0 to 4 second, right? 0 to 4 second the value of velocity was constant, but from 4 to any time t, the value of velocity was actually a function of time, minus 10t plus 90 dt, right? And on the left hand side I will be having simply s minus s naught, but s naught is 0 actually, the initial displacement was 0, so actually it will become simply s, right? So s minus s naught, but s naught is 0. So this will become actually 50 t, and limit is from 0 to 4, plus this will become what, minus 10 t square by 2 plus 90 t, right? And the limit will be applied from 4 to t. This will become 200. When you apply the limit, you will be simply multiplying 50 with 4 plus this thing. Let's see what this becomes actually. This will become minus 5t square plus 90t, and the limit is from 4 to t. Let's apply the limit now. It will become 200 plus minus 5t square plus 90t, plus 5 into 4 square minus 90 into 4, right? So upper limit minus lower limit, so this will become plus, and then the second term will become negative. So this is actually, I just open the bracket also when I apply the lower limit, right? So all are clear how I did that? If you evaluate this whole thing, this should become actually minus 5t square plus 90t, and all the constants number should add up to finally minus 80, right? So s is equal to this whole thing, a second degree polynomial at the bottom, a function of time, right? So here constant acceleration was given, we integrated, we get a linear equation for velocity, we integrated one more time, get a quadratic equation in displacement. So now since we determined s versus t, so we can answer this question, what is the value of s when t was 8, what is the value of s when t was 12, right? So it is simply a matter of putting t equal to 8 and t equal to 12. So s is minus 5t square, so minus 5 into 8 square minus 10 into 8 because it was minus 10t, right, minus 90t, sorry, minus 80. So it was minus 90t minus 80, right? So when you put that, you will get s at t equal to 8 second equal to 320 feet. And similarly, when you apply s at this is at t equal to 8 second. Similarly, at t equal to 12 second, you can simply replace t with 12 second minus 5 into 12 square minus 90 into 12 minus 80. That should give you, sorry, here is plus actually. If I go back, here is plus 90t. So I should have a plus here and also a plus here. This should actually give you 280 feet. So at t equal to 8 second, distance was more, but at t equal to 12 second, the distance reduced, right? Which means somewhere between these two time instants, the particle changed its direction. If it was previously going away from you, now it is coming towards you, right? It changed, reverse its direction. So that can also be interpreted when you actually plotted that v versus t relationship, because v became 0 at exactly t equal to 9 second, right? So at t equal to 9 second, you see velocity is 0. So actually t is equal to 9 second was the instant at which particle changed its direction. It was going away from you, but at t equal to 90 it turned and now it is coming towards you. So which means that when the part C is asking us to determine the maximum positive x coordinate, maximum value of displacement, it means actually it is asking us to determine s at t equal to 9 second, right? So again C part will simply be using the same equation. You can simply put in C part s is equal to minus 5 into 9 square plus 90 into 9 minus 80. This should give you s as 325 feet, right? So it went as much as 325 feet and then start coming back to you or change its direction, and at 9 second it was at this distance, and that can be confirmed that velocity was changing its sign at t equal to 9 second. It was becoming negative from a positive value, right? So now this part C doesn't require you to do much calculations. It simply wants you to understand that whenever velocity changes its direction, you should be able to physically interpret it that displacement also changed its direction. So which means the maximum displacement which that particle took was at the time when velocity was 0, and that time you already know it was 9 seconds. So simply put 9 as a time in your s versus t relationship and get this number as 325 feet, right? That was the case when acceleration was constant.